Hey stats, we're jumping right into chapter 5, so this is section 5.1 that we're going to start. I'm going to split this up into two videos, so you'll watch the first part today and then the second part tomorrow. So 5.1, they start us off with some vocabulary for probability distributions. The first one is a random variable. And a random variable is just a variable that has that can be assigned a probability. So I'm going to say variable like x that has a probability of happening. Like a random variable would be like flipping a coin and it coming up heads. So we can assign a probability to that random variable of having a head show up on a coin. A probability distribution is lists out the random variables along with their probabilities. Probabilities. Okay. I'm going to go down to the bottom down here where we look at a probability distribution before we fill out the rest of that. So we're going to kind of skip around here. We're going to fill out this probability distribution for births of 3 babies. Okay. So when we're talking about births of 3 babies, I'm going to list them out over here. We could have a boy, boy, boy. We could have a boy, boy, girl. We could have a boy, girl, boy, or boy, girl, girl, okay? And we're going to keep listing these out, but let's first determine how many combinations there are. So if I'm having 3 babies, 1, 2, 3, the first baby could be a boy or a girl. That's 2 combinations. The second baby could be a boy or a girl. That's another 2 combinations. Third baby could be a boy or a girl. That's another 2 combinations. So 2 times 2 times 2, there is 8 total in this list, okay? So I'm halfway through. The first 4 are going to start with boy. The last ones are going to start with girl. So girl, boy, boy, girl, boy, girl, 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 boy, and girl, girl, girl. Okay, those are all of my combinations. Those are all 8 of my lists or combinations of boys and girls. Okay, now when we make a probability distribution, it does not look like this. The probability distribution actually looks like this guy over here. Okay, we're going to list out, and what I could have out of 3 babies is I could have 3 boys and 0 girls. I could have 2 boys and 1 girl. I could have 1 boy and 2 girls. I could have 0 boys and 3 girls. Those are the combinations that I could have. And then what we're going to do is I'm going to add a column to this. We'll call that P of X, and that is the probability of each one of those things happening. Okay, so out of this list of 8 that's over here, I only had 1 combination out of the 8 that had 3 boys and 0 girls. And 1/8 as a probability is 0.125. Okay, so that's 1/8. 2 boys and 1 girl occurred here and here. 2 boys and 1 girl. Okay, so there are 2 combinations out of 8, which is 1/4 or 0.25. 0.25 is the probability that I'm going to have a 2 and 1 combination, because order, we're kind of taking order out of the picture there. Okay, 1 boy and 2 girls is the next one. So 1 boy, 2 girls, 1 boy, 2 girls. Did I skip one? Oh shoot, I did skip one. Shoot. Get rid of this. There are 3 out of 8 combinations. Because this one is a 1 boy, 2 girls. Shoot, 3 out of 8. So that's 0.375. I knew I was going to do something wrong. Okay, moving on. 1 boy, 2 girls is here. 1 boy, 2 girls, 1 boy. Gosh dang it, I'm screwing this whole thing up. Okay, so now we want to look at 2 boys, 1 girl. So 2 boys, 1 girl happens here. 2 boys, 1 girl happens here. 2 boys, 1 girl happens here. So there are 3 combinations out of 8 that will give me 2 boys, 1 girl. So that is a 0.375 as probability. And then we look at 1 boy, 2 girls. 1 boy, 2 girls happens here, here, here. So that is another 3 out of 8 probability, or 0.375 as a decimal, that I will have 1 boy, 2 girls. And then probability of having 0 boys, 3 girls would be 1/8 or 0.125 again. Okay, so just kind of thinking these as decimals. If I have 3 children, which I do, I have a 12.5% that I'm going to, or 12.5% chance that I'm going to have 3 boys and 0 girls. I have a 37.5% chance that I'm going to have 2 boys and 1 girl. This is the combination that I actually have. I have 1 boy, 2 girls, which I had a 37.5% chance of having, and then I have a 12.5% chance of having 0 boys, 3 girls, which I almost had, if Kason wouldn't have been my 3rd child. Okay, so this is what a probability distribution looks like. It lists out all the combinations, and then it kind of takes into consideration how many of each combination you have. Okay, so that's a probability distribution. All right, now we have things called discrete random variable and continuous random variable. For all of the stuff going forward, like the table that we just did, we are only going to deal with discrete random variables, which are countable things. Countable variables. Okay, and what I mean by that is we can physically count how many boys and how many girls there are in a data set. Okay, we can physically count how many times the coin shows up heads or the coin shows up tails in a data set. Okay, a continuous random variable. I'm going to say the measurement recorded can be a decimal that continues forever. Okay, so what I mean by this is, like, if we're talking about temperature, let's say, okay, temperature, you have 98.6 degrees, but maybe it's not exactly 98.6 degrees. Maybe it's 98.59 degrees, or 98.599 degrees, or 98.5999, or 99999. And I could keep adding decimals onto there and continue going out forever. Your thermometer will only give you probably 1 decimal place, but keep in mind that that is a rounded temperature. Your temperature is probably not exactly 98.6 on the nose. It's probably closer to like 98.59999 or something like that, where it's rounded to 98.6. So a continuous random variable, the measurement can have a decimal that continues on forever. Okay, temperature is one of those. Time is another one, because you can have 30 seconds, or you can have 30.1 seconds, or 30.11 seconds, or 30.111 seconds. Okay, so time is an infinite decimal number that continues on forever. Distance is the same way. And that's kind of how that goes. Okay, so let's go down here. You guys have a sheet of paper that also looks like this guy. And then you will have some on your homework assignment that I post online that will give you kind of questions that are exactly like this. So let's go through just number 1 real quick, where we talk about whether it's discrete, continuous, or not a random variable. So part A, the time required to download a file from the internet. That is continuous, because that decimal could go on forever. Maybe it's 30 minutes, or 30.1 minutes, or 30.12 minutes, or 30.12753 minutes, whatever. B, the number of light bulbs that burn out in the next week in a room with 13 light bulbs. That is a countable number, so that's going to be discrete. C, the eye color of people on a commercial aircraft. Okay, that one is not going to be a random variable, so I'm going to put NRV for not random variable, because eye color is a category, and we're looking at numbers we're looking at quantitative variables for these. So random variables, discrete random variables, continuous random variables are only going to be numbers. The amount of rain in city B during April, that's going to be continuous, because we can have, half an inch, or 0.56 inches, or 0.567 inches, or blah blah blah. That decimal could go on forever. The number of people with blood type A in a random sample, we're talking about number of people, and that is countable, so that is discrete. The time it takes to fly from city A to city B, there we're talking about time again, which is kind of like A, so that is going to be a continuous random variable, okay? So hopefully that kind of made sense to you. You'll have 2 questions like that on your homework assignment that I will post online for you to fill out, okay? A couple more things. Before we stop, let's see, probability distribution requirements. Okay, every probability distribution must satisfy each of the following 3 requirements. Number 1, there is a numerical, not categorical random variable. So eye color is a no. You cannot have eye color. Okay, it has to be some something that you can categorize, like the number of heads versus the number of tails, the number of boys versus the number of girls, that type of thing, okay? Has to be numerical. Then all of the probabilities have to add up to be 1 or 100%. So down here, these probabilities that I have, they have to add up to be 100%, okay? Otherwise, it is not going to be a probability distribution, okay? Last thing, the probability of each one of the subcategories has to be a probability between 0 and 1 for every value of the random variable. So each one of these, like the 0.125, the 0.375, these guys are all numbers that are between 0 and 1, okay? So there's those 3 requirements. All right, let's consider tossing 2 coins with the following random variable. We have the number of coins that land heads, okay? So number of heads when 2 coins are tossed, okay? They are specifically looking at heads, okay? If you would create this table and want to talk about heads and tails, heads, tails, okay? We're going to use these numbers 0, 1, 2 for heads. That would mean 0 heads, 2 tails, 1 head, 1 tail, 2 heads, 0 tails, okay? So you can kind of like they basically eliminate this middle piece right here, because it's kind of implied. You could figure out what those probabilities are, okay? Now, this one has a 0.25% chance, or 0.25 chance of happening, a 0.5 chance of happening, and a 0.25 chance of happening, because 1 and 1, you could have a head, a head tail, a tail head, or a tail tail. So head tail, that combination shows up twice as 2 categories. That's why that has a 50% chance of happening, okay? And then they've mapped this out right here, and what we're going to start talking about or leading into in the next part is that this resembles a bell curve, okay? So that's kind of the direction that we are going, all right? So that was example 1, coin tosses. They didn't actually want us to do anything with that. All right, don't worry about this P of X, that thing yet. I want to talk about 0 plus. We've talked about this thing before, but 0 plus is just a fancy way for saying something that's really, really, really close to not happening, like has a very, very, very low chance of happening, but it still could happen. We call that 0 plus. We don't just put it has a 0 chance of happening or a 0 probability. We put 0 plus. That just means that it's not going to happen very often. Very slim chance of happening. Very slim chance of happening. Okay, so numbers that would be counted in this category would be like 0.0000003 maybe. So that would be like a 0 plus as a probability, okay? All right, example 2, we'll look at this guy, and then we're going to calculate a mean, and then we'll stop, okay? We won't do variance and standard deviation until the next video, okay? So job interview mistakes. Hiring managers were asked to identify the biggest mistakes that job applicants made during an interview. So they said that 50% of them had improper attire, 44% were late to the interview. Oh my gosh, that's just stupid. Lack of eye contact, that one's kind of hard for some people, 33%. And then 30% were checking their phone or texting during an interview. You guys should know that you don't do that. So does the table describe a probability distribution? So if we look at those 3 categories, this is numerical data. Check, that works. The probabilities have to add up to be 1. We're going to look at that here in a second. Number 3, the probabilities of each category have to be between 0 and 1. I think that one checks out. Each one of these numbers right here, the subcategories, are all between 0 and 1. But that second category does not work because this adds up to be like 157%. So what this tells me from this table is that maybe some people who had improper attire were also having bad eye contact. So maybe some of those people were counted in there twice, okay? But this is not a probability distribution because it is 157%. And that's what it adds up to be, so that does not work. Okay, so when we're trying to find the mean or the average, this is the last thing that we'll talk about. This is kind of easy. The mean or the average of a probability distribution, we take the x's, which are these guys right here. X's are the number of coins that were tossed with a head. And we take that times each of the probabilities. So I take 0 times 0.25, I get a number. 1 times 0.5, I get a number. 2 times 0.25, I get a number. Okay, and then this little symbol right here means I sum them all up together. I add them all up together, and that's going to be my probability. Okay, so they're going to have us do that down here for this data set. So 0 times 0.25 is just going to be 0. 1 times 0.5 is 0.5, and 2 times 0.25 is going to be 0.5, and if I add all of those up together, my total is 1, okay? So what that means is when I am tossing 2 coins, because that's all I'm tossing here, the number of heads when tossing 2 coins, okay? When I'm tossing 2 coins, on average, I can expect to get 1 head, okay? Which makes sense. If I'm tossing 2 coins, I can expect that on average, one of them is going to come up to be heads. The other one is going to be tails. So that's how I calculate the average, is I multiply these guys together, and then I add them all up. I take the total, okay? So the average is the easy part, okay? We're going to do variance and standard deviation in the next video, so not too bad of stuff today, okay? I do have the homework posted for this section already online. You guys can go ahead and log on and do like the first, I think, 4 problems is what you could probably do, okay? So log on to there and see what you come up with.